So, like we've said, this revision task is going to go through and you're going to make a foldable that goes through all the stuff that you need to think about when working scientifically. First thing you'll do, get your sheet of paper, fold it over so it almost opens like a cupboard. It needs to open up like that or else it won't work, because you can get all the information like almost on the doors, and that will leave a nice big central area where we can do an example. So if you want to put a small title, working scientifically, you can. Don't spend any real time on that. You don't get marks in an exam for going and writing a title. Right, underneath that, 3 types of variables: dependent variable, independent variable, control variable. Every question that gets you to look at any investigation, you will need to comment on those 3 variables. Remember, your dependent variable is what you're measuring. Your independent variable is what you're changing. Your control variable is what you need to keep the same every time to make sure that you're only looking at changing one thing. It's, if you think about it, what you heard at primary school, your control variable keeps it a fair test. We don't use the phrase fair test because it's not really correct, but that's kind of what it's getting at. So that's what you'll do on that first door part there. Right, second door, right, so making an investigation precise. Right, measurements. What sort of measurements are we going to make to get it precise? Right, are we going to use measurements that are far apart? Are we going to use measurements that have a small scale, etc.? Hand in hand with that, look at intervals. Explain what an interval is. So an interval is the distance between 2 variables. So if you're going up, if you go 5, 10, 15, 20, your interval would be 5. If you went up 1, 2, 3, 4, your interval would be 1, because there's only 1 in between each reading you're going to take. Make sure you do a nice smooth cut there. Then underneath that part, on the inside part, types of equipment. What sort of equipment are we going to use to make it more precise, and why? So you're going to use a measuring cylinder that has small intervals in between. If you're timing things, remember, you're going to talk about using a stopwatch because it will go in, it will measure things in 100th of a second, etc. Right, underneath that, you're going to do types of graph. I want you to go sketch a small graph that shows positive correlation. So remember, that's going to be a line graph. One that shows negative correlation, and just right small at the bottom, because we all know what a bar chart is. You can look up examples of those. Right, on this first bit, this inside part here. Right, first half of it, types of error. We get random errors. Right, a random error is just something that happens at random. It does kind of what it says. So a random error might be because something happens. It might be because there's suddenly too much light if you're doing a photosynthesis experiment. It might be because if you're stretching a spring, there was suddenly like part of the spring broke or something. Right, so that would be a random error. A systematic error is almost an error where is the same error being made every time. So if you've got a piece of equipment, so if you're weighing something at different points, if your set of scales already said 200 grams when there was nothing on it, then every one of your readings is going to be 200 grams above. Right, so that would be systematic because all of your readings would have that error. Underneath that, little section on anomalies. Remember, an anomalous reading is a reading that doesn't fit the pattern. If it's on a graph, it's a reading that doesn't sit on that line of best fit. Go and do something like that. Underneath there, so in that part, a little bit on making estimates, what causes uncertainties, brief description. Right, in this central part then, using all of that, I want you to just go and plan out and think about how you carry out an investigation into stretching a spring. Right? So, you'd need to go write yourself up a bit of a method. Right, you can go and look that up. I personally would go draw yourself a diagram of your equipment there, a method underneath or to the side. I don't want loads and loads of detail. I just want a brief method. Right, then underneath it, there are some key things that I want you to state what they are, thinking about what we've already done. So, what is the independent variable? What is the dependent variable? And what are your control variables going to be? Right, over this side. What is the intervals going to be between each? And finally, how are you going to make it more precise? So go through method, diagram, those 5 things need to be stated underneath. If you do all that, that should put you in good stead for most of the things that you'll need in terms of practical stuff for paper 1.